Look at your hands for a second. They feel solid, right? The chair you his phone in your pocket. The stars you see at night, all of that is stuff. Everything we've ever touched or seen is made of this normal material. But here's the problem. If you weigh everything in the entire universe, every planet, every sun, every grain of dust, it only adds up to 5% of what's there. 85% of the universe is missing. It's like looking at a massive, heavy bridge and realizing that most of the bricks are invisible. You can't see them, you can't touch them, but if they weren't there, the whole bridge would collapse instantly. Scientists call this the invisible wall. They call it dark matter. I'll be straight with you. If you stay here until the final minute, you're going to see why we are actually the odd ones out in our own neighborhood. By the end, this ghost house we live in will finally make sense. And you'll understand why the very ground beneath your feet depends on something that technically shouldn't exist. A few years ago, the common thought was that our math was just broken. It was easier to believe that humans were bad at counting than to believe the universe was hiding a massive secret. But then we looked at how galaxies spin. Think about a merry-go-round at a park. If you spin it too fast, you have to hold on tight or you'll fly off, right? Galaxies are spinning so fast that they should be flying apart. The stars on the edges should be launched into deep space like pebbles from a slingshot. But they aren't. Something invisible is hugging those galaxies with a grip so strong it defies the laws of gravity we use to launch rockets. I'll show you what that grip actually is in a moment. But first, we need to address the mistake that most of us make when we look up at the night sky. We think of space as empty. We think it's just a big, dark room with some light bulbs scattered around. The truth is much more uncomfortable. There is a specific reason why we can't find this missing 85%, and it's not because our telescopes are weak. It's because we've been looking for things when we should have been looking for the interference. In the next few minutes, I'm going to walk you through the one experiment that finally cornered this ghost. The light doesn't hit this wall. It doesn't bounce off it. It's like the universe is playing a game of hide and seek, where one side can walk through walls. We've always been told we are the center of the story, but the data suggests we are just the 15%. The rest? It's something else entirely. And there is a very specific reason why this invisible wall is actually the only reason you haven't been flung into the dark void of space yet. So, why is this invisible stuff even a thing? Why didn't we just ignore the missing numbers and move on? Because of a woman named Vera Rubin. Back in the 70s, she noticed something that effectively broke the rules of the universe. She was looking at spiral galaxies, just like ours. Now, logically, stars close to the center should move faster, and stars at the very edge should move slower. It's basic physics. Think of a figure skater spinning. When they pull their arms in, they spin like a blur. When they stretch their arms out, they slow down. But when Vera looked at the galaxies, she saw something impossible. The stars at the very edge were moving just as fast as the ones in the middle. They should have been flying off into the dark, but they weren't. It was as if an invisible hand was holding them together, preventing the galaxy from shredding itself apart. This brings up a question that most people find a bit creepy. If this stuff is everywhere, and it's holding galaxies together, is it inside us too? Right now, as you're watching this, trillions of dark matter particles are likely flying right through your body, through your brain, through your heart, through the floor. And you can't feel a thing. It's not like air. You can feel wind. It's not like water. It's more like a ghost that can walk through a mountain without touching a single atom. Some researchers spent decades underground, in giant tanks of liquid xenon, just waiting for one of these ghost particles to finally bump into something. And do you know what they found after years of waiting? Total silence. Nothing. Now, a skeptic would say, if you can't see it, touch it, or find it in a lab, maybe it's just not there. And honestly, there is a small group of very smart people who believe exactly that. They think our understanding of gravity is what's actually broken. But there's one specific image from space that makes that argument very hard to win. It's a picture of two massive clusters of galaxies crashing into each other. When they hit you, the normal stuff, the gas, and stars got stuck in the middle, like a arc crash. But something else, something invisible, just kept going. It sailed right through the crash as if nothing happened. This bullet cluster is the closest we've ever come to seeing the ghost's footprint. But if it can sail through a galaxy crash, what happens when it hits a wall it can't pass? There is a limit to this ghost's power. And in the next part, I'm going to show you why this 85% of the universe isn't just sitting there being invisible. It's actually building a cage. A structure so large that our entire galaxy is just a tiny speck of dust trapped inside one of its bars. Wait until you see the map of the cosmic web. It's the moment you realize that the universe isn't a chaotic mess. It's a design. Look at this map. This is called the cosmic web. It's a map of the entire universe. And it looks surprisingly like the neurons in a human brain. But here is the catch. Those bright dots, the galaxies, aren't the structure. They are just the decorations. The actual bones of this web are made of the 85% we can't see. Dark matter isn't just a random ghost floating around. It acts like a scaffolding. Early in the universe, it formed these massive filaments across space. The normal matter, the stuff that makes up you, me, and the stars, simply followed the gravity. It's like water following a pre-carved path in the dirt. Without this invisible framework, galaxies wouldn't just be flying apart. They never would have clustered together in the first place. It makes you wonder. We spend our whole lives thinking we are the main characters of the story. But looking at this map, it's clear we are just the moss growing on the side of a much larger, invisible building. But there's a problem with this perfect picture. Lately, as we've started looking closer at the smaller galaxies around us, the math isn't matching the observations. According to our computer models, there should be thousands of tiny satellite galaxies swarming around our Milky Way, held there by dark matter's gravity. But when we count them, most of them aren't there. It's like the blueprints for a house called for 1,000 windows. But when you show up to the construction site, you only find 10. This gap has led some researchers to a very controversial idea. They are starting to suggest that maybe dark matter isn't a thing at all. Maybe we don't need a ghost to explain the universe. Maybe gravity itself just works differently than Einstein thought. It's a massive gamble. If you change how gravity works, you risk breaking every other law of physics we use. But if the dark matter particles don't show up in our detectors soon, we might be forced to choose between an invisible ghost we can't find and a set of laws that don't actually work. I'm going to show you the one piece of evidence that makes the broken gravity idea almost impossible to believe. It's a signal coming from the very first light in the universe. And it suggests that this invisible wall is starting to shift its grip. Wait until you see what happens to a galaxy when its dark matter begins to redistribute. It's the first real sign that the cosmic glue holding our neighborhood together might be less stable than the textbooks say. So, where does this leave us? If 85% of the universe is an invisible wall we can't touch, and the other 15%, the part we live in, is just a side effect, what is the final move in this detective story? Most people think the mystery ends when we finally catch a dark matter particle in a lab. We've been waiting for that click in our detectors for 40 years. But while we were looking down into our sensors, the universe started showing us something much more urgent up there. Scientists have recently observed galaxies that seem to be losing their dark matter. It's not leaking out like a gas. It's more like the gravitational anchor is simply failing. When that happens, the galaxy doesn't just sit there. It starts to puff up, gets messy. It loses the structure that allows stars, like our sun to stay in a stable orbit. This brings us to a possibility that doesn't usually make it into the textbooks because, frankly, it's a bit unsettling. Some researchers are starting to ask if dark matter is a limited resource, if it changes or decays over billions of years. The cosmic web, the very bones of the universe, isn't a permanent statue. It's a living thing that might be getting older. I told you at the start that you'd never look at the night sky the same way again, and this is why. When you look up, you aren't just looking at light. You are looking at a fragile balance. We are the 15%, living on the surface of an invisible ocean. We've spent our whole history studying the foam on top of the waves, thinking that was the whole world. But the ocean underneath is what decides when the waves stop. The real invisible wall isn't just something out there in space. It's the limit of our own understanding. We are at a crossroads where we either find the ghost, or we admit that our laws of gravity were just a lucky guess that worked for a little while. But there is one place where this invisible wall is actually visible. It's not in a telescope, and it's not in a lab. It's a specific distortion happening right now in the center of our own galaxy, and it's moving faster than it was 10 years ago. If you want to see what happens when the 85% starts to push back against the 15%, you need to see what's happening at the heart of the Milky Way, and that story starts right here in this next video.